You know, one of the things to perhaps consider is finding a different way to get the angle. A lot of you have never used a trig chart before. I don't know why your teacher neglects doing it. It's a lot easier and it's more tactile. I'm going to go down to the sine column, which is, right here. And I'm going to go down until I find 0.125. The closest I get, 0.122, which corresponds to 7 degrees. This is what your calculator is doing when you put in the inverse sign of some decimal. But it just spits out a number, and a lot of you have no clue whether it's doing it right or wrong. In fact, some of you even now never check to see if your calculator is in degrees or radians. Not that you changed it from yesterday, but you might have. Trig chart kind of prevents you from making these kinds of mistakes. So know this, but when you look at the sine chart, the numbers are all decimals, all the way. The only one that can have a number greater than 1 is the tangent. But the sine and cosines all have to be less than 1. So when you get a condition to which one we do, so it doesn't make much of a difference to me. I think I performed number 1 in third period, so I'll see if I can post both videos, but I'm only going to do one. So do me a favor, tell me the conditions of problem number 2, because I don't have it pulled up in front of me. Okay. I still will have to ask the same question. All right, so the runway's due west. So I'm just going to interrupt you not to... I just want to get some things down. Due west. That's the direction I have to land. Great. What else I got?
The wind is blowing 25 meters at an angle of meters per second at an angle of 30 degrees north of east.
Okay, so that's the wind. And I'm sure I gave you something else prior about the plane.
The plane has to maintain an airspeed of 100 meters per second.
150? 100. Okay. So these are the parameters of the problem. When you're trying to solve these, generally the set of steps we talked about is still going to be the set of steps that will successfully solve these. However, it does require a little more foresight and a little more decision making. So let's start by kind of getting an idea of what the wind is doing, and then compare that to the way the plane has to actually land. I don't have a coordinate system established, but since I've established already what direction is west, the wind is 30 degrees?
Yeah.
Okay,
Yeah, but it's the same
no worries. So if I establish that this direction is north and south and east, 30 degrees north of east suggests that the wind is like that. Any questions about that idea? Now, before I actually start solving the problem, I'm going to have to make some considerations of what direction I think the plane must be traveling in order to compensate for the wind. And a quick look at the wind suggests that the wind, relative to the runway, has a component in this direction and a component in that direction. Now, I have to assume that the plane is going to have powerful enough engines to compensate for the fact that the wind is pushing it backwards, away from the runway. But the plane also has to counter the fact that the wind is pushing it to the north of the runway. I think we're looking at either this quadrant or this quadrant for the plane's velocity, so that it has a component that is to the south. Fair enough? That's because the wind has a component to the north. I don't think it is particularly likely that pointing the plane that way will allow me to go west along the runway. We want to be traveling to the west. So I think it best for us to say that the plane must be facing somewhere in this third quadrant. And I don't know how much, but I'm just going to make up some picture of what the plane is doing. Okay? Now, I'm going to set this aside. I'll come back to that in a minute. I'm just going to use that to help me set up what I'm going to do next. Because what I'm going to do next is, although I think a little bit of overkill, judging by what I'm seeing in the room, there are some people who need this amount of overkill. So what I'm trying to say to you is that if you're struggling, before you just throw in the towel, I should see all of this in your work. Okay? So I'm going to separate out the wind and the plane. And for this moment, just like we've been talking about, I'm trying to figure out the rectangular components of both of my vectors. One thing I saw yesterday, and I saw it enough where I'm trying to be very diplomatic here, is you're trying to do too much in one place. You're putting everything on one coordinate system or one set of axes. Separate them out. You'll be happier. The wind starts east, moves north 30 degrees. There are still a few of you who that alone is trouble. Length of the vector, 25 meters per second. I need to come up with the x and y components of the wind's velocity. So judging by the picture I've drawn here, I'm going to wrap a triangle around the angle, enclosing the angle in a right triangle. I'm trying to use the same vocabulary and phrasing each time, and I'm really gearing this towards the people who didn't have much to show me. Tomorrow, I don't want to see a 0 on your report. I'm giving you all the things that you need tonight to make sure you can be up to speed tomorrow. Are you writing these things down so that you can reproduce it tonight? Now, I've wrapped a triangle. This is my adjacent side. This is my opposite side. So the opposite side is 25 sine 30 degrees. I'm not writing out the whole trig stuff now. If you came to trig boot camp last night, you know that you probably have some work to do because doing the trig has been challenging for you. But this is going to be the result, which is just 12.5. The adjacent side, 25 cosine 30 degrees, which it's got to be like 21.7, half of 433. Now, those represent the two components, but I need to look here to recognize which one's x and which one's y, and whether they're positive or whether they're negative. From what I've put here, it looks like they're both positive, and the adjacent side is in the x direction, and the opposite side is in the y direction. So, 21.7 x hat plus 12.5, 12.5 y hat. Both positive. Any questions yet? All right. The plane's angle is unknown. When I drew it in the little picture, I drew it relative to the negative x direction. So I'm going to continue to be consistent. I'm going to draw it relative to the negative x direction. I don't have the angle though. All I have is the plane's airspeed. Yep?
So what if you have an angle
It could go on either side. So I could have just as easily chosen this to be my unknown angle. You're just going to find the complement in the end.
And that's when you would do like the degrees of the in the final answer.
That's how we do what?
Like in the final answer, how to review the degrees and the direction.
Yep. But we are finding the angle that we're going to point the plane. But changing, like, this is west and this is south. So the angle I've selected now is the one that's south of west. The other one is just west of south. And they're complements, so it's okay. So I'm good? Keep going? All right, so same set of steps. I'm going to wrap a triangle around the angle, even though the angle is unknown. It's a right triangle. This is my opposite side, and this is my adjacent side. And I'm still going to express what the opposite and the adjacent are. Opposite is going to be 100 sine theta. Any question about that? Okay, adjacent, 100 cosine theta. Okay, I'm kind of skipping a bit ahead. I'm not writing out sine theta as opposite over hypotenuse and then solving for it. If you need to do all of that, then by all means do. It just takes time, and that's okay. We have time. But this next step, a little critical. The adjacent side points in the negative direction. So when I go to write this into the x-coordinate, I better explicitly make it negative. The opposite side also explicitly acts in the negative direction. So I need to explicitly state that it is negative. That's going to be pretty critical here. So I have converted each vector to polar, but I don't really know the plane's vector. I just know that it's got a point in the third quadrant. I think that's the hardest part. So are there any questions about how we got here? Because I'm going to shift now and do the other part. So now that we've done that, I can ignore those pieces that got us here and recognize that for the plane to safely make it across the runway, it can't be drifting north or south, which means it needs to have a velocity of 0 in the y direction. Now, this sum here between these two, that will actually be the ground speed of the plane in the x direction. That's still the resultant vector. We know the resultant vector is going to be west. We are creating that condition to happen. But that's still the resultant vector. So what I'm going to do first is handle this right here. I'm still adding down the column. So taking this and adding it to that, so that's 12.5 minus 100 sine theta equals 0. Intentionally setting it to 0. This is going to give us the angle that will cause this. Now, I had this question come up already, so I am going to be a little more explicit. First, if you work this out and you get a negative over here, something is wrong. All right, your sign is going to have to be a positive number. I still have students who are having a difficult time dealing with. My sine is 0.125. So on the trig chart, it looks to me like the angle is going to be 7 degrees, but I know if you put it into your calculator, you get 7.2 degrees. So we now have the plane's heading. And based on this picture right here, the plane's heading is 7.2 degrees south of west. Your answer wouldn't be complete if you just said 7.2. So that's the first question. Any follow-up? You guys have anything about that? Because we're going to go on to the next part now. All right. Now, before I go any further here, please understand that this fraction has to be less than 1. If you reach this point and this fraction is greater than 1, then there is no angle that can safely have the plane travel in the direction you want it to go. The wind is too powerful. It comes right. These two vectors. I need the plane's vector to be more powerful than the wind's vector. And it is in this case. But if the wind's vector was more powerful, then the top number would be greater than the bottom number. And that would be a condition that there's no answer. You might think you've done something wrong, but be prepared for null answers to show up on the test. This is the condition. So if you work this out and you find that the sine of the angle is equal to a number greater than 1, there is no such sign. Where they're telling you the sine of your angle is greater than 1, no, it's not. That doesn't mean that you've done something wrong, though. Now, if you get negative, that means you did something wrong. Now, we're not quite done. You're supposed to get the ground speed of the plane. That is the resultant velocity of the plane. And that part's just taking the 21.7, this one, subtracting the 100 cosine 7.2 degrees. And finding out how fast it's traveling. Be careful here too. You could get an angle earlier and then plug it in here and find that the plane is traveling to the right if it uses that angle. You do understand that the plane can't travel to the right. There's no runway there. It has to travel to the left. So this answer had better be negative. If it's not, the plane is not going to land. You don't think of these kinds of things when you're doing these problems, but you need to. You need to understand what the null conditions are. And those are the null conditions. A sine greater than 1 or a cosine greater than 1, or a velocity that will not successfully go in the direction you need it to go. I don't know what this answer is, but it's probably close to 71 degrees, 71 meters per second. What is it? 77. Now, your answer would be incorrect if you just said negative 77 meters per second. You should say 77 meters per second west. Yep.
So,
The runway is due south. So here's our 3 pieces of information. The runway is due south. The plane speed has to be kept at 75 meters per second. And the wind is 15 meters per second, 30 degrees south of west. I want the plane's heading. And its ground speed. So the first thing I want you to do is just kind of sketch a picture of what might be happening. So I'm hoping you sketched a real quick planes. I'm sorry, the wind has got to be. Oh, not getting any of that right. Plane this way. Sorry, wind this way. So plane has to be somewhere over here. So that gives us a start that the plane's going to be somewhere in the fourth quadrant. That's probably a good place to begin. Tuck that away. Quick sweep of the room. Gonna have the wind down here someplace. 30 degrees there. This is 15. So something like that. And adjacent and opposite. So opposite equals 15 sine 30, and adjacent equals 15 cosine 30. All good? So x hat, y hat. I'm noticing the adjacent is to the left, so it had to be made negative for the x direction. And the opposite is downward, so I need to make the y direction negative as well. And although I can do 15 sine 30 and get 7.5, oops, 7.5 y hat, I don't have my calculator to do 0.866 times 15, so what's the x one? 12.9. That good?
Yeah.
I would keep more decimal places in between steps. I think you'll be happier. But this is all I'm going to write. Now the plane, we don't know what direction it has to be. I just know it's got to be down here someplace. And just to make things different, I'm going to choose my angle to be here. It doesn't matter whether I choose the angle between the x-axis or the y-axis. Okay. Going to wrap this angle here. I'm going to call this one the adjacent side and this one the opposite side. List the plane speed as 75. I do want to point out that the adjacent side is negative. The opposite side is positive. So opposite, 75 sine theta. Adjacent, 75 cosine theta. So opposite's the x direction, 75 cosine theta, x hat, minus 75 sine theta, y hat. Yes.
Would anything be changed if you would from the angle on the upper side of that quadrant?
The only thing that's going to be different is that you probably had sine with your x and cosine with your y. That's what you did? I don't know if y'all heard that question, but if you had chosen this side to be where theta is, then these would change places, and you'd have sine on the x side and cosine on the y. The angle's going to be different if you do it this way, but they're going to be complements of each other. So they're just going to differ by 90 degrees. Which one of these do you make 0, though? Yeah. I can't hear, but it looks like I wrote them down backwards.
Find the ground plane of the plane. So you do for the Y.
Hold on, I'm not listening. And you probably want me to. Thank you. You're the best. Oh.
Sure? I could
Yeah.
tell them too. Pencils? I don't know.
I don't. Thank you.
Have a great day.
You too.
So for the ground speed, you would.